An identity graph stitches together different identifiers into a unified view of people, the households they belong to, and the devices they use. Why identity is so important for advertisement? First of all, people use multiple devices and screens daily. Identity enables cross-device and conversion addressable advertising. It helps it to be more efficient. So you can do household consumer frequency capping. You can actually achieve like better reach for your consumers. So you can do audience extension to linked devices. It helps advertiser to have more lift. So you can do, for example, conversion attribution across different devices. So you, for example, you watch an ad on your mobile and you decided to buy it on your desktop, then we can able to connect these two actions together and help you to increase your lift.
By using TigerGraph, a native graph database, understanding and mutating relationships is more intuitive and easier to model than traditional databases utilizing countless table joins. We've found TigerGraph's key strength is about identifying and maintaining relationships between our ID pools.
So we have a large distributed graph with over 5 billion plus vertices and over 7 billion edges. Every single day, we make up to 1 billion new updates to our graph. Every time we run our identity resolution algorithm, we are creating up to a few 100 million more vertices and 1 billion more edges. Now we have a beefy TigerGraph cluster with over 400 gigabytes of RAM per node. But when you are running breadth-first search style algorithms, like label persistence on a large graph, it's very easy to run into memory problems since it's extremely memory intensive on a per node basis. We can continue to add more RAM to our nodes, but at some point, we're going to hit a ceiling and we need to be able to scale our algorithms horizontally. When you're building a graph solution, you need to exercise graph thinking. If you try to build your graph with a relational model in mind that relies heavily on building indices, and your queries work by creating joins and where clauses on these indices, you're not going to get too far in the graph world. As a graph-native database, TigerGraph stores related vertices adjacent to each other and allows you to traverse these relationships extremely fast without having to use indices. TigerGraph is extremely configurable and you should tweak it to fit your specific use case. Whether you're trying to get super fast query times or you're trying to run heavy graph processing algorithms, setting the right configuration on your cluster will make all the difference for you.